Welcome to the CAD Class Podcast. We're your hosts. I'm Josh.
I'm Jake.
And each week we talk all things CAD, Fusion 360, making, prototyping. And this is a good episode, Jake. We had some happenings. We had some drama.
We've had a very busy, lovely week. Yeah.
We had some drama this week. So if you're here in the chat, say hello. We always love to interact with you all. But we're going to lead this week with the drama. So I'm guessing that if you're here, you've probably heard something about it so far. But Jake, what happened?
Yeah, maybe. So a big part of what Josh and I always try and do is make all of our content as accessible as possible. We've got a video course, which for some people is just a little bit too expensive. That's perfectly fine. We can get our book, which has the exact same content on Amazon. If that's still a little bit too dear, we give all of our book away completely for free on our website, literally every single page, and it gets updated continuously. We get contacted by a lot of teachers around the world, actually, not just around the country, saying, do I have to buy 30 copies of your book for all my students? Go, absolutely not. Download it for free and then print out whichever projects you want, Share the love, spread the joy is all about what we're about. But unfortunately, very recently, we found out that somebody has been selling our book on Kindle on Amazon, unfortunately. They have essentially just downloaded the book and then published it on our page.
And I discovered it because I was on our Amazon page. Our sales were slowing a little bit for our hardcover and our paperback, which was, they do ebb and flow. But I go into our Amazon page, and what do I see? I see a Kindle copy of our book.
That's right. We don't do.
Which we didn't do on purpose. We didn't do it because you and I had a long discussion about we couldn't control the formatting. We knew that if you were going to read this on other devices, the only way we could control the formatting was if it was PDF. We knew that Kindle has too many different sizes and things like that. So we purposely didn't do it.
Mm-hmm. PC Van Fleet says, what probably doesn't know is that just by Amazon's rule, if we publish something on Kindle, we are not allowed to give away the PDF for free elsewhere. So if you want the PDF for your class, but you don't own a Kindle, too bad. We're legally not allowed to give it away. So we just said, we would rather give it away for free rather than make a couple bucks here and there on Kindle sales. It's like, whatever. But yeah, that popped up with like a really crappy, squished in, low resolution version of our cover. And it just looked terrible. And we were like, well, this isn't proper. So Josh went ahead and contacted Amazon's customer service, who responded literally like less than an hour. They've been absolutely fantastic.
Less than 2 minutes.
Oh, sorry. Less than 2 minutes.
Left my phone number. They called me back. I said, hey, there's somebody stole our book, basically. So you know what they did? This is really interesting what they did. So they actually created an account. I don't know under what email service, but they created an account called Sliceform LLC at something email address. So they took our business name, created an email address out of it, and were able to fool Amazon into thinking that it was actually us because it had our business name. I was like, oh my goodness. So fortunately, I said, I think this is fraudulent. And they said, it's not fraudulent. What it is copyright infringement. So you need to contact our copyright department. Yep. So luckily, they took it down within 20 minutes. The book was already delinked from our page. And within about 30 hours, it was completely wiped off the page.
Completely right.
And thank you to our audience. So some of you actually who went on and bought the book left a negative review because you're like, hey, what is this garbage formatting? This is actually terrible. So thank you. It's really nice to be a part of the community who's doing this. Ethan says it's not that hard to trick Amazon. Well, we just found out. So
I know. So we have a now higher security built into our Amazon account. So highly unlikely to happen in the future. But but as soon as Josh told me, the first thing I thought was, oh great, it's good enough to steal. Awesome.
Yeah, I know.
I was super happy with it.
Such a good response. We wrote a little Twitter post and it was like, I think we said something like, well,
if it was crappy, nobody would steal it.
But it's kind of nice to know somebody would steal our book. But also, it's somebody stole a book that we give away for free. So it's really bizarre. I don't actually know how to wrap my head around that. So
that really sucks.
To the book thieves out there who take what we have already given for free, screw you. Screw
charge for it. Screw you. You suck.
Yeah, but PC Van Fleet says that's true. It's a compliment. It is a compliment. Wow, we wrote a book worth stealing. That's awesome. That's such a nice perspective.
That's right.
We have one question. I wanna do some shout outs to projects, but I see that David Dickens also has a question right away. So we always said when you come in here, we want to be able to answer your questions and help you get that help right away. So I actually had a plan. I wanted to show off some of these cool projects, but since David was bold enough to ask a question right here in the very beginning, let's go ahead and answer one of his Fusion questions, and then we'll shout out some of the awesome projects that we've seen come in this week.
We've seen a few
on our Discord.
We've seen a few that come on our Discord page. Either they get posted onto the project section or they get posted on the I Made a thing, which we absolutely love. It's one of my favorite parts about what we do is when I see people actually say, oh, I used what you taught me to then, 3D print or laser cut or woodwork or make something in real life with the skills that I've developed from the program. And we absolutely love it. Absolutely love it. It's one of our favorite bits. So if you haven't done it yet and you have 3D printed something, please post it.
Put it up on I Made a thing. Put
Josh
it up on it, please.
Love it.
Please. I have an idea too, and we're going to answer this question really, really quickly. So I have an idea of something that sounds kind of ludicrous at first, but what if we tried to put on a 1-minute CAD competition? What can you design in 1 minute? Or like some
very
ridiculous time constraint. or 4 minutes, right? You're on the clock.
I have a better one for you. So I know. All right. So in the CAD community a couple of years ago, there was this really fantastic challenge that I really dig. And just for a little bit of context, so in the engineering CAD world, if you go to engineering school and you take a CAD class, not us, but a literal CAD class, your final or one of your exams is going to be, here's a top, a front, and a right view of a product, some dimensions, and you need to recreate it in, let's say, 10 or 20 features or less. It isn't good enough that you made it. You need to do it efficiently. If you do it in 25 steps, too bad, you failed the class. So you need to do it and think and be really creative and be as efficient as possible. That's the big thing. And so a couple of years ago when the Cybertruck got released and people were like, well, it's so angular and so kind of crazy. People said, I made this in 8 features and 8 steps. Who can beat me? And it was fantastic. It was people from all different types of different CAD programs, and we absolutely loved seeing it. So it was really, really fun. Maybe and I think I'm one of the very few people that actually really like the Cybertruck. So whatever.
Yeah, wow.
You don't like it?
It's something. It's a statement.
It is wild. Yeah.
Maybe what we do though is we build this idea of challenges into what we do. So I think both could work, and I think I like the idea of minimizing features. I also really like the idea of just as fast as you can prototype it. What can you do if we give like a simple challenge?
Yeah, which is what happens in real life as well. Your employer usually says, "I'm going to give you a day. Go."
Yeah. All right, so let's answer our question, and then we'll dive into show off some awesome projects. So David Dickens says, currently on page 77, trying to get my head around the Lego block. I'm looking at page 77. David, are you still here? If so, do us a favor and tell us what about page 77 you're trying to get your head around.
Go ahead and present my whole screen. So I'm not going to see Josh's beautiful face.
Yeah, but they still see it, so you're not going to see it. Too bad for you.
So let me go ahead and open up not the Lego brick, but the plastic building brick for legal purposes.
Yeah.
I love saying that. That's going to be in our mechanical design section. So let's open up our Lego brick. All right,
so let's see if David. Yep, the little rectangles did not stick to the side walls. The little rectangles did not stick to the side walls.
Okay, I think I know what you're talking about.
Okay.
So let me get. So it looks like. So if you guys can see right here in my timeline, I've actually got a ton of errors on here, and that's just because on this project I've selected to pattern both the tapered cylinder and the text. So I'm just going to unselect that extrusion. Oops. I'm just going to redo it, to be honest. I would like to extrude the cylinder and the taper to it, but not the text. I actually don't care too much about it. And I'm just going to go through why it's giving me all of these errors. So it looks like it's kind of slowing down a little bit. Yeah, the shell operation really doesn't like Fusion very often. It's massive pain.
Yeah, we've had to tell people many times now, especially in the Discord, you can't, for some reason, the letters really mess with this shell function as do other things.
Mm-hmm.
They are on the underside. Yeah, I see that, David. We're going to go to the underside here in a sec.
So it's definitely something that you do later down the line. And there you go. Things are corrected a little bit more. So on this page, you would then is he saying just the extruded rectangles right here?
Yeah. So let's see. The little rectangles did not stick to the sidewalls. Let me just put his comment up here. Okay. So by the little rectangles in the sidewalls, I presume you mean those. Yeah, those on the sides there. Right there. And yeah.
Okay. So they're moving back and forth a little bit. So there's a couple different ways that you can correct this. One of the ways would be to use the collinear tool and select the two edges that should be meeting. If you guys can see this, it then makes all of the lines black and fully defined. That's great. That's what we're looking for. All of these should be completely defined and locked down in place. So if they're not, you definitely need to do just a little bit of work on this. It looks like this one is movable again. So again, I can just add on some collinear constraints. The other way to do it is as you pull up R for rectangle tool, you actually don't click in the empty space and make a rectangle. You can actually click on the projected edge first. You can see I have this little X there. And that lets you know that immediately it's going to be applied with a coincident relationship. So then when I drag, it's not even going to be moving away. I can still adjust the dimensions and where it is in the page, but this top edge is always going to be attached to it. So I'd probably, again, either add on that collinear constraint or actually maybe potentially redo the rectangles a little bit.
And that, so he says, can you show us what tool that was? So David, that was the collinear tool. So the collinear constraints. Yeah, so in the constraints toolbar in the top, you can click the drop down and hover down to collinear. When you click the collinear tool, you're going to select two lines, and that puts those lines on the same plane.
So I'll do it again. So as the name implies, collinear just means two lines that share the exact same axis. So if you had one line here and one line right above it, they would not be collinear because if you extend them, they don't run into each other. So even though they're parallel, they may not be collinear. It's in the exact same area as coplanar. If I put a cut onto a coaster, the top of there and the bottom of there are coplanar. So very similar things. They exist on the same area.
So David says, perfect, thanks. But we have another comment that said from Tim, says he didn't select join.
Didn't select join. So that is automatically selected. Join is the top feature. So if I just go to
join,
extrusion,
are you talking join or joint?
Join.
Join. Yeah. Okay.
Yeah.
Oh, I
so right here.
Okay. Yeah.
Yep. So when you extrude things, it needs to have an operation. So it's going to say immediately join. If it sees that your extrusion is actually passing through something else, then it's going to be automatically set to cut. So I'll just do a really quick example. So instead of selecting this bottom surface, I'm actually just going to be using the arrow tool for this, and I'll actually push this through the underside. Oh, and you'll see it's automatically set to join, so I can change this to cut, and now it's red. It's actually going to be cutting out that shape through the body, which looks kind of wild.
We got an awesome Ethan, very smart. All right, so welcome back, by the way. Wait. On the last episode, didn't you say we should never put two lines on top of each other? Jake, what do you think?
This is two. This came up on the Pooch show. Yeah. So this is not two lines that exist on the same area. This is an edge of a rectangle that is collinear with another edge, which is completely okay because I'm not going to be moving them side to side. I'm going to be moving the rectangle. So what was it, Ethan?
Yeah.
So what Ethan was talking about, what Mr. Alan Pooch was talking about last week is that he was doing this, where he had one line and then he also had another line. And as you can see, it's really hard to click on just one line. I'm moving my mouse like minutely, and it can't decide one line or the other. This is where we actually don't want to be messing around with. In our scenario, we have a larger rectangle and another rectangle right here, where I can define, the length and the width of this, and then I can decide exactly where it is side to side. But the very top edge of this rectangle and the top edge of this rectangle, they already share the exact same collinearity, so I don't need to worry about that whatsoever.
So I think Tim's question isn't fully answered. He says join during extrusion. I'm guessing Tim
join during extrusion.
Yeah, I'm guessing what. So when you're sketching in 2 dimensions, you are constraining sketches. We're not actually dealing with the join tool at all. So join actually refers to what happens when 3D bodies either intersect or cut. So it has only to do with the 3D portion of this. So the question
so
that
there is
David
no
had
join
was,
in the 2D sketch.
right. So the question that David had was, when I can move my rectangles around, they're not actually connected to the edge of the Lego brick. So how do I stop that from happening? Because you're in the 2-dimensional workspace, you're talking about constraints, not the 3-dimensional.
You can definitely think of constraints as joints, but it's a little bit more advanced than that. In the same way, it's a little bit of that. Usually, when you talk about joints, you're talking about things physically touching each other. But a little bit more of an advanced idea in joints is that you can have an offset joint where you have 2 things that are offset. So when you move one, the other one is pulled with it because there is an imaginary joint between the 2 things. In the same way that you can have a defined distance, a dimension between 2 objects in the sketch universe.
Yep.
So kind of similar. I'm liking where your brain is going, but try not to think too deeply about it because it just get too confusing at this early stage.
Definitely.
All
right, so I think we should do some shout outs. Also,
I think we should definitely
if you're here, please give us a like, leave us a comment, do something like that. It's awesome. I think that's eventually how YouTube will decide we're interesting and important, if they ever do. I don't know, but if you, I'd also want to know something as we're pulling up people's projects. Could you just tell us in the chat where in our book or online course or where in your in our universe are you right now? Which project are you working on? It's sometimes hard to gauge where everybody is. So just let us know in the chat where you are. And Jake, so we've got some projects to show.
Yes, we do.
Somebody made so we do the phone case and the phone stand in chapter 5, I believe.
In chapter 5. So this is already really rad. So the idea with the phone stand or with the phone stand and phone case project, the big idea is obviously, as Josh and I are educators, very often the project that we're doing, the purpose is not to make a phone case or a phone stand, because how often is that going to be useful? It's the little things inside it that are kind of more interesting. So in this project, we talk about either importing a file, a Fusion 360 file, into Fusion, and then you can interact. So if you go onto a place like GrabCAD and someone has a Fusion 360 file, you can actually show you how to import it. That's rad. We also encourage you guys to grab your smartphone and then measure it with a pair of calipers and recreate it, so you can have a little bit of reverse engineering that is gigantic in the world of CAD. And then we make a case to then introduce the idea of interference and then how to adjust and edit that so you don't have 2 bodies clipping through each other. And then finally, we make a little phone case stand just to introduce the idea of texture map controls, because this is the appearance chapter. So if you have a wooden project, you can actually really accurately adjust the grain pattern of the wood to make it as accurate as possible. What a lot of people do, a lot of our previous students who have a ton of woodworking experience, they will actually take what they learned from this, from our course, and then make a woodworking project, make it in CAD, and then sell it before they even make it. And then as soon as someone says, hey, that table looks rad, I want to buy it off you, then they can make it. So they don't need to buy something or buy all the lumber, make it, photograph it, and then store it and then hope that maybe one day it'll sell. So it's way more efficient. So making wood looking accurate is the kind of the main game. But Milk Tea right here then took an extra step and made it way more interesting that we do in the course, which we always really love. And then they went ahead and 3D printed it in this really rad purpley blue galaxy. Damn, that looks awesome. Love so cool. Seeing it. Really rad. And then the other one was the fire piston as well. Milk Tea again. Kind of
Milk Tea with the...
Really dig it.
Yeah.
You guys that are seeing this and you're going, wow, that looks really different to my workspace. This is the rendering workspace. So this is where, which we cover in chapter 9 of the book, or week 9 in our course. This is where you can pull in your 3D print, or all of your models into a different workspace, add the design into the rendering workspace, and then you can add some lighting and some shadows, mess around with the camera a little bit, and then you can make something that looks a little bit more photorealistic. And if you really put some time and effort into this, you can fool people into thinking that this is a real product.
Yes.
But this looks really fantastic.
I love the way that turned out. And then there was a Mr. Mitnick had one, which
I'm not sure if I saw that.
Let's see. We have a bunch of people that have stuff in the challenges as well.
Oh, yeah, that's right.
I believe was that. I just see an M for that.
Yeah, somebody's working on the on an ice cream scoop, which I'm so excited. Awesome. That's gonna be rad.
This is how you get better at CAD, right? So you get better. All the people, all of you in here who are doing some of these challenge exercises, who are forcing your brain into the mode of I need to be able to make this thing, and go from us holding your hand to you are actually designing this in the real world. This is actually how you learn. So love seeing this stuff. That's what IKEA does with their kitchens. That is what IKEA does with most of their online catalog. Yeah.
Yeah.
Hey, PC Van Fleet. So PC Van Fleet, Mr. Mitnick is him on the Discord. So shout out to you. Shout out to you. That's awesome.
Love to see it.
It's funny to put those two together. It's like you don't quite know who's who. So awesome. Thank you so much for being active and commenting and encouraging other people to ask what I saw. I think I saw it might have been you who was encouraging somebody else to explain an answer to a problem that they had when they solved it on their own. I saw that come in. So great job encouraging other people to answer their own questions after they figured them out on the Discord for everybody else to get that information. That was awesome. Okay. All right. We're going to talk the Bolt.
Let's do it. Let's talk about the Bolt. Yeah.
Yeah. And
so we had some people.
If you're just coming into the chat, do say something in the chat there. And also feel free to post your questions. We're answering those live. So, all right, let's talk Bolt.
Let's talk bolts. So the metric bolt is in chapter 3. This is when we go over the parametric design. This is when you can actually introduce different parameters. So then you can edit really anything about a bolt. So if you go, all right, well, this is a thread length. This is a M5 by 25 millimeters. I want to change this value to something like 25. Or excuse me, let's change it to 50. Then I can click OK. Oh, whoops, that should auto update. What's going on? Oh, the length. There we go. I want to change this to an M5 by 50. Then it automatically updates very, very easily. And then you can say, well, I actually only want the threads to be on 25 millimeters. There we go. Then it auto updates. So that's the value that I was changing around. So you can really quickly edit parts of any models incredibly quickly. You can customize them very easily. Let's go ahead and change this one back to 25. Very, very cool project. I use parametric design all the time. If I'm working on a 3D printed part and I want to maybe adjust the size, but I want to keep the wall thickness exactly the same, I can mess around with it in a bunch of different ways. But one of the things that somebody was having trouble with is the triangular profiles that give us these really nice cutouts here on the bolt entrance and on the very end of the bolt right here. So they were just having a little bit of trouble. Where are the triangles that are being revolute cut? And so this is where we can kind of sort it out. So one of the ways that I actually kind of like to figure out exactly where my sketch is in the timeline, you can absolutely go through and name all of them, or you can click through the sketches on here and actually find out exactly which one it is. So there's a bunch of different ways to find out what you're looking for. But on here, we have our revolution cut. As you can see, that's cutting out the very end of our bolt, and the entrance of our bolt. So we have got, where is this sketch? Let's slice it. Where is this sketch? There we go. So just going to slice that and cover it. So we have got this triangular profile right here, and we have got this triangular profile right there. And let me turn off the body really quick, because this is how we have it in the book, where we just have our dimensions. So if you look in our book, we actually have our origin right here, which is letting you know this is on the left-hand side. We've got a triangle facing upwards, because this is going to be cutting the entrance of where the Allen key would be going into. And for this scenario, we've got an equal-sided triangle. So we actually only need to define one edge length of this triangle. And then we're saying that the left-hand side is coincident with our origin. And then we just need to say exactly how high is it up and down. Again, this can be, any one of these dimensions can be parametrically driven. So you can edit them as much as you would like. But this is going to be on the left-hand side. But the really funky one is over here. So we actually projected the original sketch, the original revolution of our project, the original sketch of the bolt. And this is what these purple lines are right here. Again, this is just going to be a very simple equal triangle, 45 degrees, not very exciting. But the really funky thing about this triangle is that we actually added on some extra lines right here. This is this kind of funky, undefined section of the sketch, because if you just revolve this triangle alone, very often it doesn't cut all of the bolt. It leaves you with a little sliver of material, so you can actually extend the profile that's being cut. So if I go over to our revolution, you can see we've selected not only that triangular profile, but also this outer material, so then we can guarantee that we're cutting all of the material. And then after that, if I turn our body back on, you can see that we don't have any weird sliver of material hanging out over there. And we have this really nice, neat triangular cutout on our hexagonal opening.
Yeah, and I think that probably helps. We'll find out. We might also consider, I mean, each time we get these comments, we try to figure out how to go back into the book and make these changes. So
absolutely.
We might have to change out some of
the entire book about every month.
So we might have to just show like an overall view, I think, of this,
this
bolt, and then where exactly those triangles are. I'm not sure. We'll see. We'll dive back into the book and have a look. But I love this idea, though.
I think the other thing that kind of confuses people, just to interrupt you really quick, is we have two different things that we're revolving in the same sketch. So we've got, obviously, these two, you can select them both. That's fine. But then we also have this other profile over here, which for a beginner kind of seems like totally dissecting a sketch. Normally you would say, all right, I'm going to sketch this, then revolve cut it. Then I'm going to sketch this and then revolve cut it. But the nice thing about this is that they both share the exact same axis of revolution, which means they can both be cut in the same revolute cut feature. And because they can both exist on the same plane, they can actually be merged in it. So instead of having one sketch, one revolve cut, another sketch, and another revolve cut, we can actually half the amount of features and compress it so it's all in one thing.
So and let's dive actually a little bit deeper on that topic. So when you're thinking about keeping things clean, like when you're thinking about designing a project that's sort of scaling and getting bigger and bigger over time, like the amount of features that you have matters. The amount of operations that you make matters. Can you talk a little bit about philosophically how you think about keeping things clean and doing it in fewer features, and why that even matters, what difference that makes?
So it's more of a organization thing for me, where if you have a timeline down here, which is not very long, that's great. If you've got a timeline that isn't very efficient and it's super long and you have to scroll through it, it gets more confusing. Things get lost. You forget what changes need to be made. And it is just kind of bad form. It comes into the area of, I could be a better CAD person for me in the future, or I could be lazy for me right now. So if you go through your sketches, you can actually right-click it and you can rename it. So right at the beginning, I was kind of hunting through all these sketches about, hey, where is that profile? If I wanted to be even more of a good engineer boy, I could go ahead and rename this triangular revolute cut profile. That would be really easy to change in the sketches as well.
Yeah, and I think there's something I want to double down on that as well. It's like you're not naming things so that you remember what they're called today. You're naming things so that you remember what they're called next year. When you dive back into a project you haven't seen forever, it's the same with code. When you're coding something up, if you don't leave any comments and your code isn't very clean and you just can't figure out what the heck you actually did. The same thing happens in CAD, where you need to know what the heck it was. And so, yeah, you can kind of figure it out, but keeping things clean and tidy and reducing the number of features that they have, adding names to them, allows you to go back into those designs much later. It allows also other people to go into those designs and understand your process and your thinking and make edits necessary to do that.
Yeah, definitely. I would say that in the world of CAD, when you're talking about organizing something, a really good example is they say, oh, if you're ever working in a team where you've got multiple people, maybe you're working on a rocket, maybe you're working on a robot with a small team of people, and you're constantly changing and adding parts, and it's kind of an alive project. I would say that's as effective as an example as saying that when you actually work for yourself for the future, because having another person is probably going to know just as much about this project as you will in a year or 2 years, which is very little. And so designing something with that kind of fail-safe built in is absolutely critical. So adding in names, adding in parameters, so you actually know all of the important dimensions are already listed, and then you'll have really good names, and everything is nice and neat and tidy, and you don't have a timeline that you have to scroll through to find that one thing, is absolutely critical.
And for those of you who want to do this professionally, for those of you who are interested in turning this into a career, this stuff really matters. If you're talking to an interviewer and they ask for a CAD model that you've built and they see a timeline that's just out of control and not very organized, they're going to have a sense of what kind of designer you might be, and they might judge you on that alone. So I think it does matter quite a bit for any of the students we have that are thinking about taking this into engineering fields and or even designing for clients. It definitely matters.
Definitely, absolutely.
Cool. Well, if you're new in here, give us that thumbs up. We think that helps. I don't know, something like that. Refer us. Yeah, tell people about us. That's awesome.
Yeah.
And definitely bring you're welcome to invite people who haven't been here before. Send them a note, tell them to hop in. They might learn something. They can ask us their questions. We love to have people. So any questions, just a reminder, any questions, pop them in the chat. Otherwise, are we done with that one, Jake? I think we've got another one in.
I think so, yeah. Yeah, give me another one.
All right. So our next one is, let's see. This was page 66. Is that correct?
Oh, yeah, for the filament guide.
Yes. Third paragraph on page 66 was giving somebody some trouble. Let's see. 66. Third paragraph. One,
that filament guide.
Oh, that's the project tool. Yeah. The project tool is hands down. We talk about it every week. The project tool is the hardest tool to understand what the heck it actually does. Just keep playing with it. But we'll talk briefly about this. We'll try not to say the same thing every week. But page 66, third paragraph says, press P for project and click the rightmost and leftmost vertical lines on the arms. Add a tangent constraint between the arc and this new line. Can you just do that exactly at what I'm saying? And let's see.
Okay, so I'm going to type P for project. You can see I've got my project tool right there. I'm going to click the rightmost and the leftmost vertical line and click OK. I have now projected this top edge onto, which is floating above my plane, onto my plane. If you can see that. So now I've got purple edges on the left and right. Then if I add on a couple 3-point arcs that go to that line, I'll just do some random ones here and there. You can see this one automatically put on a tangent constraint just because I nailed it because I'm a professional. But I can also go into the constraints, check on tangent, click on my arc, and then click on that projected line right there.
I see. So I actually see, I think what we'll do in the future for this project is we will show more of that, of the projected surface. So on page 66, I can see where you can barely actually see the lines you're supposed to project. So I actually think I do understand where that is tricky for people, okay. this brings us to a topic as you're continuing to work on this that I want to talk about as we're going through this as well, and that is we are thinking about getting rid of some projects and adding new projects for version 2 of our book to come out probably middle of the year next year. So anybody in the chat who's got an idea for a project or a tool or an area of Fusion that you'd really like to explore, any of those ideas, please do shout those out either in the Discord or live on this chat. We are actively working to build out a few new projects.
We never want to be having a project that is so like cemented in place. We always want to be updating the projects, making them nice and new and fresh so you guys learn as much as possible. This is going to be in the first chapter of our book, in the first week of our course, where we talk about single parts, where it's just one thing that you're dealing with. It doesn't have multiple assemblies. It's as simplistic as possible. So just for reference, we build a Mobius strip. We build a surfboard. We build a Lord of the Rings ring. And we have our filament guide, which is a very, very handy tool for our 3D printing nerds out there, I myself included in there. But this is a project that a lot of people that we've heard is just that little hair too difficult. We obviously want to challenge people, but we don't want it to be a pain in the ass of a challenge. So if any of you guys have any single part ideas that are cool and exciting and interesting, absolutely post them in the chat. It's a bit of a philosophy for Josh and I that every single project that we do anywhere needs to be interesting and exciting. If it's boring, absolutely not. Nix it.
Yeah, so the boring project, I think, and it's like twofold. One, it's boring. It's not as interesting for most people, but also this one might be a little bit too challenging.
It's a little bit tricky. Right from week 1.
Yeah, for early on.
Which is absolutely an acceptable stance. If you say this is too hard, that is absolutely okay.
Totally.
That's absolutely a reason for us to reconsider changing it around. So again, if you guys have any ideas, definitely send them our way, and we'll definitely consider them. We've got a couple rattling around.
Definitely. Okay. So hopefully that answers some questions on the filament guide. Again, I think I understand where the pictures are not doing it justice. David Dickens says the text on the ring. This has been a common problem as well. The text on the ring getting squished, I think, was part of the... We'll see here. So the text on the ring could not get it perfect.
Yeah, this is... so the decal section of Fusion is really rad, but it isn't perfect. Everything about Fusion is purely representative. So if you add a decal onto a curved surface, it's going to be projecting essentially a flat picture onto a curved surface. So the very front, where you put it on there, is going to look really, really accurate. As you can see, if I just... There we go, perfectly. It's then getting stretched as it goes around a curved surface. So it gets just a little bit deformed as it goes around. This is not your computer. This is just how graphics work. So don't worry too much about it. There is no perfect nature in this. This is purely just an example to show you how to get an image, a JPEG or a PNG onto your model. If you guys are ever doing any client work for anyone and you're doing a CAD project, the coolest thing for that client is to take their logo and put it onto a 3D model. They go absolutely bananas for it.
Yeah, they love that.
Love it.
So David also says, do you not run it all the way around the back? No, we didn't run it all the way around the back. But again, this is not a precise, has to be done a specific way project. So this is just what you find looks good for you. So play it around.
This is purely representative. Don't worry too much about it. All right.
So PC Van Vliet says, we asked him, what would you want to see? And he says, tough question, but I like projects that help you think in CAD. Let's see. It's like a language where you need to take a certain approach. I find myself thinking of an object and not really have a clue of how to start with it. So that I think is actually pretty common because I like your language analogy. We actually talk quite a bit about that. Learning CAD is actually learning the language of 3 dimensions. And Jake, I also like one of the things that you do is you look at all of the objects, say, on your desk. So PC Van Vliet, look at all of the objects right now that you have on your desk and start to try to think in your mind about what the object looks like and what shapes it's composed of and how you would actually go about making that physical thing. So I've got like a lens cap. I think the 3D Print General did a lens cap on his, and he redesigned that lens cap. And that's one of those things.
And it took him like 4 or 5 iterations, which is tricky. It's a very tricky thing.
Well, and that's one of those things where it's like, you look at, when you think of it originally, you're thinking, well, this is just a circle extruded and, shelled out and things like that. But really, like, there's a lot of small features on this, a lot of shapes that are either cut from other shapes or added to other shapes. So it has to
you
do
guys can
with
see that this is what he's talking about, where it's essentially a flat circle, and then it's got some indents on there. Oops, there we go. It's got some indents on there that need to be really, really accurate to go onto, to actually mesh into a camera body. And if they're just barely not the right dimensions, then you don't get a nice tight fit. There's not enough friction buildup. It's kind of jiggly and wobbly, and it isn't effective. So, yeah, it's a very, very tricky build.
So thinking in CAD, you're learning to think in shapes that are added and subtracted and cut from one another. Definitely. So you really have to look at as many objects as you possibly can, and just picture in your head if it's an addition, a subtraction, or a join between two different shapes. And that's about it. That's really all. Even when you think of manufacturing, those are really the only 3 processes. It's either additive, where you're building things up from nothing. It's subtractive, where you're cutting them out, or it's combinatory, where you're putting them together.
Yeah. A really good example that I kind of like for a lot of people is just like a very simple cup or vase that you have, probably on your desk. I've got this little vase that holds some grass in there, but you can kind of start to think about things in the geometric space, where you go, okay, well, this is kind of a cylinder. So I think this would be a really good example where we break this down as simply as possible. So when I look at this, the first thing that comes to mind is, all right, it's round, it's got a round profile, and it's got some height. So this is a cylinder, essentially, yeah? I think we can all agree that it's got some cylindricality to it. Okay. But then you'll say, all right, but it's got some kind of curvature to the outside of this. You can go, okay, well, let's kind of mess with that a little bit. I'm going to draw a little sketch of some kind of arc going on here that kind of cuts into it just a little bit. It's kind of matching what this profile looks like. And then I'm going to make some lines so that's actually a clickable profile right there. You can go, all right, well then, that's cut all the way around this shape. So then let's go ahead and revolve this about that axis. Let's turn our body back on and click OK and go, all right, well, that's looking a little bit closer, but obviously this is a container where it's got a hollow section. It's got a wall on there. And this is obviously a solid thing, so I would then need to use my shell tool to then select that top surface and then cut out, let's say 5 millimeters or so. And there you go. You have just recreated something on your desk, and it only took 4 steps. So you can then go the extra step and go, well, can I make this even more efficient, really? And you absolutely can. If you start to then look at the world in 3D bodies, but then also profiles, you may go, oh, wait, this entire thing is actually just a revolved profile. I don't even need to do the whole shelling and then make a cylinder from scratch. I can make this in 2 steps. I could actually just go into, a sketch like this, make that original arc that we did, make an inner wall, something like that, join the top together, make a base, make an inside edge, join that too. So then we've actually got an enclosed profile right there. Let's make that top one horizontal. We can make these 2 arcs coincident to each other. We'll raise up the height just a little bit. That looks good. Now let's revolve it about that same axis. And it doesn't look exactly like what we made, but all the properties are there, I would just need to add on some dimensions to make it as accurate to this as possible. But again, I've got an arc on the end. It's essentially cylindrical, and it's hollow on the inside. And you've got a perfect thickness between the inside and the outside, which is the exact same thing as this project. It's got the same inside and outside thickness all the way along. So for this one, it took 4 steps, but on this feature, it only took 2. So I'm twice as efficient making this one as I did that one, and I got essentially the exact same outcome from it. So that's definitely something that you need to think about when you're talking about doing CAD. Is how can I reduce the amount of features in my timeline that gives me the exact same project?
Definitely. So Maple Leaf Makers on top of this says, I have a question about this cup that has been troubling me. How would you make the bottom thicker than the walls with shell?
This is a scenario where actually going into a sketch like this makes way more sense. I could say that this is, oops, not the radius. I could say that the thickness here is 5 millimeters, and I could say the base thickness is 10 millimeters. There you go, boom. This is now a really thin wall, but if I do a little cross-section analysis, you can see that my base is much thicker than my walls. Done.
Yeah. So how you go about thinking about how to make these designs, right? You don't always have to fill it. If you need to make a shape that's hollow, you could sketch something out as well. Like this is good. Extrude the bottom, question mark?
Not really what you want to do there. If I just say, if I'm just giving these two 5 and 5, so it's as if I shelled it. So if I extrude this bottom surface, let's say another 5 millimeters, you can now see I've got this little weird angle undercut right there with this kind of V-shape gap all the way around my project. So that's not exactly the way that I would do it.
So Maple Leaf Maker. Go ahead.
Sorry, go
ahead. Go ahead.
There is a tool down here called Thicken, but that's hit or miss whether that will work on your project. It's basically just very specific parameters where this will work. I doubt this will work in this scenario. Yeah, it's not a clickable surface on here, so not going to work for you in that scenario.
Yep. So with the follow-up being, but not possible with a shell? Question mark. Maple Leaf.
It is definitely possible with a shell, but again, you are just taking this this circular profile and extruding it upwards. And as you can see, the gap is forming all around the edges, and it gets worse and worse because we have an angled outwards. If it was going inwards, then technically it could intersect with it and fill a gap. But in this scenario, it's not the way you want to do it.
So different way. Okay, that's still useful, though. I should avoid shell if I need different thicknesses. Yeah, you should probably do it a different way.
Yeah.
Yep.
Shell is super handy tool. But it becomes your least best friend very quickly. It becomes the bane of your existence.
Frenemy is what it becomes.
Yes.
Okay, still useful. Bottomless gaps. Good. I love the questions coming in. All right, we had another one, which is not so much a question as I think it's an ask for future projects. Todd Phillips says, I would like to better understand how to model intolerances.
Ooh. So tolerances is a concept that we go over just a little bit in the engineering drawing section, chapter 4. Tolerances is a really, really funky topic because it gets it's very easy to understand the simple stuff, and it gets very complicated and very technical as soon as you try and creep just a little bit further into it. It's an entire class that you can take. If you want to look into the field a little bit more, the standard in America is called GD&T, Geometric Dimensioning and Tolerance. The body that governs exactly how you talk about tolerances is ASME, the American Society of Mechanical Engineers. They've put out a PDF of all of their standards where it's like 200 pages just about exactly how you tolerate something, called Y14.3, I believe is the most up to date. So that's totally a little rabbit hole you can dig into, but just fair warning, it gets crazy very quickly. Definitely look into it if you'd like. Tolerancing gets kind of wild.
And I'm not sure I completely understand what you mean, how to model intolerances. Do you understand that question, Jake? How to
modeling with tolerances, kind of. Again, I know that field, and that's a little bit too advanced for a beginner basic. I would try and avoid that topic until you feel much more comfortable in within CAD.
PC Van Fleet, I saw you guys both own an Ender 3. Yes, we do. Ender V2 Neo for Jake. I've got a modded original Ender 3 with a silent motherboard and a BL Touch I never installed. Glass bed, things like that. But he says your knowledge would be nice for modding a Voron printer. Learned a lot about printers building one. Yeah, I think. Yeah, I definitely hear you there. I think we're less focused now on 3D printing than we were before. We actually closed down the 3D print farm that we were sort of operating, not really pushing very hard. We've chosen deliberately to focus much more on the CAD side of things for people. So I've heard nice things about Voron. We also saw the Voron that was printing at absolute ridiculous lightning speed. Remember that Voron that we saw at OpenCross? I mean, ridiculously fast. That took fast to the next level. Voron is amazing. I don't see myself spending all that much time on that. I think where we try to add value is in more video content, thinking about the next book, writing out more things, so that by the way, there's the big Bamboo Lab announcement. Everybody's going bananas over now you really have this competition between Bamboo and Prusa, which is heating up, and that's really good for the consumer. And so I think what we're trying to do for the consumer side is, hey, who cares what 3D printer you own? It doesn't actually matter. We're trying to teach you how to make a model so that you can use somebody else's printer, so that you can model this up and show other people your ideas. And so I think where we're going to come at this is, how do we add value? We're selling the shovels, right? Everybody who owns a printer needs to know CAD if they want to make their own custom stuff. So we kind of view it like that. I don't know. What do you think about that, Jake?
I definitely agree. I think that a big part of us, again, I'll say this until my face is blue, is about accessibility, and the Ender 3 is super cheap, biggest community in the world for 3D printers, fairly easy to assemble, and pretty consistent. It's not spectacular amazing, but it definitely gives you the area to tweak and really improve exactly what you're making. And the Voron, I believe, is still not sold as a kit. It's still, they kind of give you a list of stuff to buy, and you have to figure it out on your own, and that's super daunting. Josh and
really
I
rad.
Both, yeah, really fantastic. But before, I've been into 3D printing long before it was a kit. Back when you want a 3D printer? Well, you have to then build not only the actual thing, but then you have to build your firmware, all the software that goes into it. You need to build functionality to your slicer, and it was a big ask. It was really only done by electronics nerds and mechanical engineering nerds and people that wanted to dedicate like a year of their life to really delving into this one little thing. So, yeah.
Yeah, totally. And we see Maple Leaf Maker says, Voron modding is the only reason I'm learning CAD. I would actually say, A, you're not alone. And B, 3D, to Jake and I, the real insight we had was, hey, the more popular 3D printing gets, the more likely it is people are going to need to learn CAD. And therefore, the more necessity there is to develop the book and the course and all these things. So 3D printing is the reason I dug deeper into CAD. It's the reason that you and I wrote the book. We thought, this is a growing hobby, it's a growing trend, and it's increasingly being used in legitimate manufacturing processes, like the 3D printed rocket body with relativity space. They're using a robot arm and they're laying down a weld bead, but hey, it's the same concept. So absolutely awesome there. If you like 3D printing, you have to give some love to the Ender. You can buy full kits now for Voron builds. LDO has great kits. Yeah, so tons of options. Awesome. The problem is with Jake and I think I can speak for us both here. We would spend all day just tinkering and building stuff and get nothing done. Right? Get nothing done. We would just we'd get sucked into the hobby too far. And so I have to be careful with what I decide to do. But awesome, yeah. I mean, 3D printing is a big reason why we're all here.
Yeah.
And by the way, Jake, so we can tease out, we do have a Ender 3 assembly course right now that we are going to build out much more substantially into a kind of an intro to 3D printing, but talking about materials and properties and different types of machines and different types of printing. And so for people that are coming into this industry who are brand new, who will be introduced to the Bamboo Labs or older Enders or whatever, we're going to build out a substantial 3D printing class here over the next probably 3 to 4 months.
It's going to be all about seeing exactly what 3D printers are, what all the bits and pieces that go into it, what all the components do and how they relate to each other, which if you've done enough 3D printing troubleshooting, then you know just exactly how important that is. We'll go into the assembly of making an Ender 3 from scratch, exactly how to level your bed properly, because the paper test is not enough. I tell people this all the time. How to go through and find print, how to do the very basics of slicing, whether you prefer a Cura or Prusa slicer, and then exactly where the world of CAD or the world of 3D printing is going, and where you can kind of advance into, where you can get into really calibrating your printers, going even deeper into your slicer, because there's a fun new bunch of new tools that are coming into that field, and exactly where you can kind of launch off from that. And usually CAD is always the next step, but as everyone knows, as soon as you buy a 3D printer, you just print everything that you've ever wanted off Thingiverse and printables, and then after like a month you go, all right, what now? And usually the next step is, all right, I want to make my own stuff, and then 3D print it. Yeah.
I mean, I have a feeling that's why all of you are here. Is you've decided making your own complex models and making your own custom stuff is way more interesting. So,
Which it is.
Cool. Let's see. Feeling under 3, totally understandable. Own 2 printers now, looking to 3rd build. Yeah, love printing. I love the innovation coming out. So again, the whole Bamboo Lab thing, heating this competition up. I just love to see all this competition. Another one, not sure if you guys are familiar with the Voron Stealth Burner toolhead, but it's got a low poly look they call stealth, like the bomber, and achieving that look is challenging. Tips. I haven't seen it, so maybe that's a tip for next week. You're gonna have to pop back in next week, because we're only about 4 minutes out of closing this stream, and I doubt we'll be able to answer your question substantially. So tune back in next week if you're still interested in that. Send us a note either in the Discord or via email or whatever works for you, with some links to what it is that you're talking about. Maybe we'll pop it up and see what it would take to design something like that. Could be a good one. We thought about today too. We thought about kind of modeling up and prototyping something completely from scratch, but fortunately we had tons of questions and comments in this section here.
Oh, I know. So, sorry, just to butt in really quickly. Let me just go ahead and share my screen. I know exactly what you are talking about. Share my entire screen. There we go. Yep. You're talking about. Oops, get out of here. About this thing right here, which is a really, really rad. It's the hot end. It's the fan, the part cooling whole system, and it looks so cool in this low poly thing. If you're asking how to model this up, I would actually recommend not doing it in Fusion, doing it in a separate program where you model the general shape of this project, still smooth or undone, whatever you want, just put some curves into it, and then export it into another very, very simple 3D modeling viewer, and they will very often have a poly count reducer. So if you guys are on Windows, then the built-in 3D viewer that's built into Windows is called 3D Builder, and it literally has a polygon adjuster. So you can say, oh, I want this to be really accurate, give me 1,000,000 polygons, or you can push that down into 1,000 polygons. And so it is a super duper easy way to reduce polygon counts and then export it as an STL, because that's an area where Fusion will really start to choke. But yeah, that's the way I would do it.
There we go. Any final comments, Jake? We got about a minute left. Keep those projects coming. Yeah. Keep asking questions. Yeah. We're very much, especially with you guys that are engaged in this YouTube with us, this live session. We love this. We are very much looking for feedback, comments, ideas, questions. We're looking for you to help drive the next iteration of what we do. So yeah. the more stuff you feed to us, the more interesting things, the more that you want to know. Share those ideas with us. We're in.
Absolutely.
We're doing this together.
If you guys have any cool project ideas or things that you want to tweak that you want to see in the next edition, absolutely send it to us. You can email, you can send a a DM on Discord. You can post it here, any which way you'd like it. We always love to hear those examples. But I think that's going to be it for this week.
Thanks so much for tuning in to the CAD Class Podcast. We will see you and your friends next week.
We'll see you later. Adios, guys.
Adios.